Hi, my name is Laura Carruthers, and I'm a PhD student in the Plant Sciences Department at the University of Saskatchewan. Today, I'll be sharing the idea behind my latest thesis chapter, Microbial Diets: How Nitrogen Sources Influence Emissions in Agriculture. Soils play a critical role in sustaining life on Earth. They are rich ecosystems where diverse microorganisms cycle nutrients to support plant growth. This is why soils are the foundation of food production. But soils also contribute to climate change. Agricultural soils are the largest source of nitrous oxide emissions in Canada. Nitrous oxide, or N2O, is a greenhouse gas that is 298 times more potent than carbon dioxide. So, where does this N2O come from? When we apply sources of nitrogen to our soil, microbes process it into forms that plants can use. However, not all of the nitrogen is used by plants, and some remains in the soil where it can produce N2O if the conditions are right. Synthetic fertilizers are generally a big driver of N2O emissions, especially when over-applied. To address this, some producers are shifting toward more regenerative cropping systems, which rely more on plant residues and other organic nitrogen sources as opposed to synthetic fertilizer. My research compares the impact of synthetic and plant-derived nitrogen sources on N2O emissions. So let's think of nitrogen like food for microbes. Synthetic fertilizer is fast food. It's quick and easy for microbes to process it into plant available forms. But this rapid conversion can also increase emissions risk. On the other hand, plant residues are like cooking from scratch. When microbes are given a basket of ingredients, it takes time and energy to break them down into plant available forms. This creates a slower release of nitrogen. My research aims to understand what happens when the system is given a nitrogen source that it isn't used to. What happens if those fast food loving microbes are given a basket of ingredients? Or if the home cooking microbes get a bag of French fries? Essentially, if farmers that used to rely heavily on synthetic fertilizers switch to more regenerative cropping practices, what will that mean for N2O emissions? My research aims to understand and answer these questions using isotope-labeled nitrogen sources to understand the relationship between management history and nitrous oxide emissions. This research will hopefully guide sustainable nitrogen management strategies to reduce the environmental footprint of agriculture while supporting productive and healthy soils that continue to feed the world for many generations to come. Thank you.